Hey, fifth grade. Our objective is I can divide 2 and 3-digit dividends by 2-digit divisors with single-digit quotients and make connections to a written method. So essentially, we're practicing the same objective that we practiced in the previous lesson, only this time with the problems that we've been given, we're going to see some interesting information that will lead us to estimating in a more accurate way. I went ahead and started out problem 1. So it's the same process that we've used in the previous lesson as well. Estimate, solve, check. We've been given 72 divided by 21, and I need to estimate before I can actually solve. So 21 is our divisor, and we always round that first. So I rounded it to 20 here, and I started listing out the multiples of 20 so that we could find a multiple of 20 close to 72. That would make this division easy. But fifth grade, I came to a little roadblock. I don't know if I should pick 60 or 80 because 72 is right in between them, right? So 80 is actually closer to 72, but it's too big. It's above 72. So I wouldn't be able to use that in my standard algorithm. We get as close as we can without going over. So that's something that's a little different than what we practiced yesterday. So I actually have to choose the smaller one, even though it's a little bit further away, because we, in standard algorithm division, we get as close as we can without going over. So my estimate will be 60 divided by 20, which is 3. Okay. That estimation means that there are about 3 groups of 21s in 72. So I'm going to record that estimate up here above the ones place, 3. Okay, so 3 times 21 is what we'll be subtracting, 3 times 21. So that would be 63. And when I subtract, I have to borrow. So my 7 became a 6, and now my 2 becomes a 12, and 12 minus 3 is 9. Is 9 enough to make another group of 21? No, it's not. So that becomes our remainder. We can say R9. But as you get older, remember you would write it as the fraction 9 over 21. That's the actual answer. So now when we check it, we divided 60 divided by 20 to get the estimate, which was 3 ones, and we tried that in our quotient. It turned out that our actual quotient was 3 with 9 left over. If I have 21 groups with 3 in each, I would be doing 21 times 3, and then I would add this 9 on. So 21 times 3, we got 63, and then 63 plus that remainder of 9 gives us 72. So our estimated quotient of 3 was really perfect. And our goal is to get back to the number we started with, 72, which we totally did in our check section. All right, let's try problem number 2. We have 94 divided by 43. So first we round the divisor, and we'll round 43 to 40. So now I'm looking for a multiple of 40 that's close to 94. That will make the division problem easy. So I'm going to list them out: 40, 80, 120. Okay, and we want to get as close as we can without going over. So the closest I can get without going over is 80. So my estimation is going to be 2. And we're going to take that 2 and plug it in over here in the ones place. 43 times 2 is what we're subtracting now because we're in the solve step. We're actually solving. And 43 times 2 is 86. So that's what we subtract. we will have to borrow because I can't do 4 minus 6. I have to borrow from this 9, so my 9 becomes an 8, and my 4 becomes 14. So 14 minus 6 is 8. 8 is not enough to make a whole nother group, so that becomes my remainder, 8 over 43. So my total answer is 2 and 8 over 43. Now when we're checking, the first thing that I did was 43 times 2, really. And that is 86. And then I have to add on that remainder. 86 plus 8 gives me 94, and that's the number that we started with. Our estimated quotient and our actual quotient turned out to be extremely close. So that's how we know that we were correct. All right, and let's do 2 more together like this. So for problem 3, we have 84 divided by 23. We start out by rounding our divisor, so 23 becomes 20, and we need a multiple of 20 close to 84 that won't go over. That will be 80 if we listed out 20, 40, 60, 80. The next multiple would be 100, and that goes over. So 80 is the closest that we can get. 8 divided by 2 is 4. And our 4 we're gonna try plugging in up here. So how many times does 23 go into 84? We're estimating 4 times. Okay, so 4 times 23 oh my gosh, you guys, is 92. So if this happens to you, and we did this on purpose, if this happens to you, you can't subtract that. That means our estimate was too big. Even though we chose a number that didn't go over 84, it still turned out to be too big. So we actually have to try one number down now. This one won't work. Our new problem is one number down. 84 divided by 23. And instead of 4, now we're gonna try 3. Okay, 23 times 3 is 69. We can subtract that, but we need to borrow. So my 8 becomes a 7, my 4 becomes 14. So 14 minus 9 is 5, and 7 minus 6 is 1. 15 is not enough to make a whole nother group, so that becomes our remainder. So 3 and 15 over 23. And that might happen to you, even though you pick what looks to be the right estimate over here. When you're actually doing the standard algorithm, it might just be too big for the dividend. So it's okay if you have to cross out like this and go one number down if that happens. So now when we're checking it, what we really had to do was 23 times 3, right? And that gave us 69. And then when we take our 69 and we add on a remainder of 15, let's see what we get. 9 plus 5 is 14, carry the 1, 6, 7, 8, 84. Yep, and that's what we started with. So if this happens to you, it doesn't mean that you don't understand the problem or that you did it incorrectly. It just means that you need to adjust your thinking. And we ended up with 84, which was the dividend that we started with. So we're on the right track. All right, we'll do one more. 57 divided by 29. So we're going to round 29 to 30, and we need a multiple of 30 that will get us really close to 57. So 30, 60, 90, 120, 60 will be the closest thing. So our estimate is 2. Now I'm thinking, can I use the quotient of 2? Well, 2 times 29 is 58. So if I did 2, it would give me this. Can I subtract that? No. So this is another example of a problem where we're gonna have to go one step down now. So our estimate is really accurate now because we have to use a 1, and that's gonna get us even closer to the actual answer. So 1 times 29 is 29, and we have to borrow. So our 5 becomes a 4, and our 7 becomes 17. So 17 minus 9 is 8, and 5, that became a 4. So 4 minus 2 is 2. 28, oh, it's so close to 29. It's almost enough to make a whole nother group, but it doesn't. So our remainder is 28. So it would be 1 and 28 over 29 is our final answer. When we check our work on what we did, we actually had to do 29 times 1 first. Equals 29. Then we take that 29 and we add on our remainder. So if we add 29 plus 28, we get 57. The estimated quotient of 2 was too big, even though the process that we've been using to formulate our estimation was correct. When we applied it in our standard algorithm, it was still a little too big. So we tried 1 instead, and that turned out to be the exact answer that we needed. Okay, so you have one question to answer before you start your practice problems, and that question is, why is it important to estimate when you're dividing with 2-digit divisors? Thanks so much.